Ladies and gentlemen, thank you very much for coming again for the second part of our workshop. We will hear more about from merging statistics and geoinformation. Perfect. Maybe put it in there. That's fine.
Yeah, maybe I'll put it in the back.
The computer responds a little bit slow.
Oh,
no, I mean, if you click it, then you just have to wait until it comes.
Okay, perfect.
Welcome.
Hello, my name is Mirosław Migacz. I'm a Chief GIS Specialist in the Central Statistical Office of Poland, and I'm going to present our experiences under the grant Merging Statistics and Geospatial Information. We have done a bunch of things in this grant. They focus mainly on demography, commuting, spatial planning, and quality of our registers. It does respond slow. Okay, this is the agenda. First, the aim of the project, then a few words about the team, then the description of tasks that were carried out within the project, and of course, the conclusions and the results. Okay, so there are two main aims that we wanted to achieve in this project. First of all, we wanted to perform geospatial analysis with use of population and housing census 2011 results and use other statistical datasets that were in our possession. Also, we wanted to evaluate reference materials that were to be used in the production of geostatistics, and these were spatial address databases. These are databases that were created for census purposes in Polish statistics. They contain three feature classes: statistical address points, which are address points with locations of dwellings, and statistical regions and census enumeration areas, and these are statistical units that are below LAU2 level. I think it's worth noting that Polish statistics in 2010, in a 6-month time, created from scratch the address point database that contains 6 million address points for census purposes, and therefore we can all data that was collected in the population housing census was referenced to a specific set of coordinates. The team of the project consisted of 11 people. 5 of them were from my department. This is Programming and Coordination of Statistical Surveys Department at the Central Statistical Office of Poland. 3 persons from our Urban Statistics Center that works in the Statistical Office of the city of Poznań. 2 people from the Regional and Environmental Surveys Department, and 1 person from the Statistical Computing Center in the city of Łódź. The first topic that we taken on under this project is spatial visualization of demographic data. As source data, we used attribute and spatial data, which I will describe in detail further on. We used various methods of aggregation to various statistical units, and of course the results were presented on maps, which I will show further on. As source data, we used attribute data that were tables with population distribution data from the population housing census. These contained a person ID. For each person, we had a pair of coordinates that were acquired from the spatial address databases that I described earlier. And so, since we have 38.5 million inhabitants in Poland, we had 39 tables, one for each million people. As spatial data, we used boundaries of statistical regions and census enumeration areas, cadastral units which we acquired from our mapping agency, and we used the EFGS Inspire 1 kilometer grid. Okay, so the grid part was the easiest one, since the cell coordinate of the 1 kilometer grid is located in its lower left corner. To acquire a grid cell ID for a specific person, we just needed to take the first 4 digits of each coordinate, and we had the result. So we didn't need any GIS software to perform this aggregation. We could use any database processing application that supported VBA. Then we used ArcGIS, though it wasn't necessary to calculate the total number of population in each grid cell. And this operation was carried out manually and separately for each of the 39 tables. So it took a while. The next statistical unit that we wanted to aggregate the population to was cadastral units. Since cadastral units are of course an irregular division of space, this time we had to use GIS software. We decided to use ArcGIS and its FileGeo database. At first we tried to process the whole data set, the whole 38.5 million objects on one machine, one server, but it unfortunately exceeded RAM capabilities of any machine that was in our possession. Therefore, we went back to the 39 tables and decided that the process needs to be automated, because for the grids it has been done manually. We used Python scripting with the ArcPy module that contains every single tool that is available in ArcGIS. The script was programmed to process the 39 datasets cyclically. First, we created a spatial join of the first dataset with persons to the geometry of cadastral units. That was the initial dataset, and then the script for each subsequent spatial join was adding the current population to the total population in the initial dataset. Pretty much the same tools were used for statistical regions and census enumeration areas. There was just a slightly different method of cyclic dataset processing, but I think I'll pass on that. Okay, so conclusions from our from the aggregation of population data that we had on points. We can aggregate data to grids without use of GIS software. VBA is sufficient. Irregular division of space requires use of GIS software, and if we have to use GIS software to process large data sets, it's good to have it automated, because after we prepare a script and test it, we can then run it on a server, and it doesn't require our attention. So we have the population data aggregated to grids, cadastral units and statistical units. Now it's time to perform a presentation. Basically, for all the presentations we use population density. We decided to use 2 different classifications in 5 classes. The first one, we chose an average value of the population density. This created our center class, and then we had 2 classes on each side. The other classification method was quantiles, which means that each class had an equal number of elements. The classifications were presented in 2 color scales. One was a 2-color gradient and one monochromatic, and the presentations will follow. This is the population distribution in a 1 kilometer grid for the whole of Poland, with the central average class. This is the same classification, just with a different color scale. It might take longer now.
Should Can I click for it? You're talking and I'm clicking?
That might be a good idea, yeah. This is the 1 kilometer grid, but classified in quantiles. It's worth noting that there is one class that was created for zero population. Now we can compare the average class classification with the quantile classification for an area of Warsaw and its surroundings. This is population density in cadastral units. Population distribution in census enumeration areas also with the classification around the central value. Cadastral units classified in quantiles.
Really?
Yeah. Census enumeration areas classified in quantiles as well. And here we can compare how the Warsaw and its surroundings look classified in quantiles on cadastral units and census enumeration areas. Which leads us to a conclusion that the difference in presentation is because the cadastral units and statistical units were created for completely different purposes. Cadastral units were created for management of land ownership, and census enumeration areas are created for census purposes and for enumerator management, and their size depends on the population count. Another subject we taken on under this grant was specialization of enterprise addresses. As I mentioned before, as I mentioned before, we created the spatial address databases, so we already had coordinates of each dwelling in Poland, but for many other analysis we also need to have coordinates of enterprises. So this is our source data. We used social insurance registers, taxpayer registers, inland revenues database, and our statistical register of enterprises that is kept within official statistics. This is only data on enterprises and address data, no coordinates yet. And as spatial data, we used spatial address databases and a database of topographic objects that we acquired from the mapping agency. So first, the descriptive information from our enterprise register in our official statistics was paired with address points from the spatial address databases, and then from address points from the database of topographic objects. The first pairing, like pairing as is, gave us 62% of address points for the enterprises. Then we had to do a bunch of simplifications to acquire coordinates. First simplification was simplifying the address number. For example, if you had an address number like 3A or 3B, we used 3 instead of the address number with a letter. That gave us another 5.9% of addresses. If there was no address point for the specific enterprise, we used the nearest address number, and that gave us another 18.6%. If there was no address number in our database, we used an address point that was on the same street or the locality centroid if there was no street. That was another 1.8%. If there was no street ID at all, and in all other cases we used the centroid of the locality, and that measured up to 100% of enterprise coordinates in our database. And this database was used for another topic in this project, which was calculating commuting statistics. First, the definition of commuter in this project. We defined a commuter as a person that had to travel to another municipality to work. Municipality is law to level in Poland. So we also used as source data both attribute and spatial data. We were surveying directions of population movements related to employment around the city of Poznań and commuting within voivodeships. A bit more data on population was acquired for this part of the project. Apart from the person ID and its dwelling coordinates, we also had information on age, gender, workplace coordinates, income, economic activity, and the fact of commuting. As for the spatial data, we have had, of course, the boundaries of the territorial division of the country, spatial address databases, spatialized enterprise addresses that I talked a while ago about, and the 1 kilometer grid from EFGS, and a few presentations of the results. This is the percentage of commuters in the whole number of employees on Law 1 level. This is a surplus of arriving and departing to work for the whole of Poland on a 1 kilometer grid. And to follow is a close-up of this surplus in the city of Poznań. The quotient of commuting flows on census enumeration area level. This is the area of the city of Poznań as well. Arriving and departing to work to and from the city of Poznań on grid 250 meters. And percentage of people that are commuting to voivodeship capitals. Voivodeship is a NUTS 2 level indicated with a dark border here. The last topic we taken on under this project was statistical indicators for spatial planning. This time we used only spatial data, source data. The scope were selected administrative units, which I will show in a moment. The aim was usability analysis of the spatial data that we acquired from the mapping agency, which is the database of topographic objects, for use to create indicators for spatial planning. We are surveying building density and road density. We acquired the buildings and road network from the database of topographic objects. We also used cadastral data, orthophoto map, boundaries of our statistical units, and boundaries of the territorial division of the country. This is the scope. 27 Law 2 units from 4 Law 1 units that are located north of Warsaw. The first stage of this project was evaluating source data. We are comparing the content of randomly selected grid cells that were within the database of topographic objects with the contents of the orthophoto map. For the roads, we sampled 59 grid cells out of a total number of 1,185. 79.7% of these cells had the total compliance with the orthophoto map, and the rest had at least 75% compliance. With buildings, we sampled 135 grid cells out of almost 3,000. 44.5% had total compliance. Another 37.8% had compliance higher than 75%, and the rest were majorly half right. Gaps were found mainly in urban areas that are strongly developing at the moment. The indicators. First, the building density indicator, which was calculated by total building area divided by a survey area, and it was presented in percents. Here is the presentation of this building density indicator on a 1 kilometer grid and on the Law 2 level. The analysis of this indicator let us found the grid cell with the biggest number of buildings and the grid cell with the highest building density ratio, and these weren't the same. The second indicator designed in this project was the road density indicator, and it was calculated by a total road length divided by the survey area. And again, this indicator presented on Law 2 level and on a 1 kilometer grid. And based on the calculated indicator for the grid cells, a road density model was created. And it's presented here. A few conclusions. As I mentioned in the beginning, we had all census results reference to a pair of coordinates. That gives us huge opportunity for spatial analysis and allows us to create geostatistical products that reflect user needs. We know that there is a high demand for demographic data lower than Law 2 level, and now we can create such data. The project in Poland had a very positive reception, so I think we can call it a success. And the project outcome will have a strong impact on what we are planning to do with our geostatistics portal, including the Inspire services that we are planning to publish. I will talk a bit more about that tomorrow, also at 4 p.m. in room 4, about the developments in the geostatistics portal that are planned for next years. That will be all. Thank you for your attention. If you have any questions, I'll be more than happy to answer them now or via media listed here. The presentation is already on SlideShare. You can find it under this address. Thank you.
Thank you very much. Very impressive presentation. The floor is open for discussions. Questions? Eva.
Concerns the special identifier of the entrepreneurs. How do you maintain change there? Because my understanding is that it's, or that is in my country, that a new organization gets this identification code, and then it's fixed to the organization independently of the location of the headquarters. If they change, they keep the older. So how do you manage the location LinkedIn to be up to date, to be used for statistical purposes?
Actually, at the moment, we don't. We created a data set with coordinates of enterprises specifically for this project. But as you've seen, we have road to recreate it again if there is a need. So when we have another project that we will need enterprise coordinates for, and we will then perform the same operations as we performed here to achieve an up-to-date data set. Thank you.
Further questions? Yeah, that would have been, I think I'm following up on Eva's question. For the moment it's like a census-based approach which you have, but you don't intend to come to a rolling register approach like other countries?
Well, actually, I think I have to add that when it comes to our spatial address databases with locations of dwellings, they are updated quarterly.
Okay.
So this is the basic data set that was the source of enterprise coordinates. So this is updated. We plan to include the enterprise coordinates in the system that is used for maintaining the spatial address databases. But for now, we just know how to achieve the coordinates when we need them.
Okay, thank you.
Thank you.
The map of daily commuters to work, from home to work, does it include cross-border commuters?
No. No, it's only on the territory of Poland. Maybe Inspire will help us in that.
Well, I think you need to convince the national statistical institutes that they report these values. Okay, thank you very much.
Thank you very much.
Thank you.
Thanks.
You want to use your machine?
Yeah, I have some links open already, so maybe it will be faster, quicker. It's
Five.
F5.
Ah, you mean for it should come automatically?
No, I think it should be pressed.
Yes, F1. Here we go. Here we go. What was that? The click in black. Now here we go.
Okay.
You want my mouse? Mehr?
No, what have I done?
You close to PowerPoint.
Yeah. Okay, in the meantime, I can start anyhow. So my name is Igor Kuzma. I'm coming from Statistics Slovenia, and I will present our work done within this grant of the Eurostat merging statistics and geospatial information. So first I will introduce what are the tasks that we will do within the grant. Then the stage, this is the application, comes from statistics and geography. So I will present the stage of development of the application and of course relation of the application to the Inspire directive. So first of all, we would, it's a part of the integrated dissemination of geospatial statistical data of Statistics Slovenia, and we would like to see it as an entry point to official statistics. You know, you can access to statistics by means of different kinds of releases that come in text forms or in tables. So this is not just the visualization of statistical data, but it should be an equal entry point when you come to our website. There should be, among everything, also this map, and you can, by means of this application, you can explore what kind of data the statistical office has, and then you can have further interest to explore the data and find them in tables and so on. So regarding the Inspire, Till a certain extent, the application will be compliant regarding the network services and metadata. We started with this kind of applications with the Casper. It was mentioned before. The Casper that comes today within the ELF project was developed from this version. We tried to disseminate the 2011 census data in some innovative way, also including the grid data down to 100-meter grid. And all data are still now available together with geometries. So basically the stage is the upgrade, or technologies that are used are actually new. So it's the logic is the same, but the application is quite new. And regarding the variables, we are trying to take into account the Geostat project that was mentioned before. It's also the project supported by the Eurostat, mainly deals with population distribution and focused on grid statistics, in one sentence to say. And furthermore, we would like to explore what kind of other data we could also disseminate on grids, like data on income, on number of cars, and things like that. Maybe just one sentence. More or less after 1995, all the data that statistical office produce can be point located, consistent through all the administrative units. So more or less what we are dealing with is how to assure the confidentiality, the statistical confidentiality of the data. It's not such a problem to locate the data. So this is what I was mentioning before. This is data presented in text. Here you can get tables. These are video clips, and there you can see it's Geostatistics portal. You can find the Casper application already here. So it should be like a window to official statistics, the application itself. That's what I was explaining before. This is how it looks from behind. It looks that it runs quite smoothly, but we will see later. I will also refer to my previous presenters some problems we encounter that was already mentioned before. So basically, if we start here from the upper left, the main input are spatial data. We upload them as shape files, as a compressed shape files. And then the statistical data come out either from PX files. PX files are derived from PX Web software. It's, I believe, developed by Norwegians, Norwegian Statistical Office, and around 25 to 30 offices, statistical offices in the world, I think, are using this for the dissemination. I mean, for the dissemination of the table data. It has also IMAP, I think it's called, that you can visualize those data on map, but you cannot download with the geometries. Of course, there is a admin. We will see, I will show later how you can manage this data. Of course, they link, Stage has its own database where the statistical data are linked to geometries, and then this is presented in a client by means of WMS. The technology behind this HTML5, because we also are planning to make it like, you know, this responsive design, that it would be available on tablets or mobile phones, because the smaller grids, like 100-meter grids, are interesting for particular users, because you can really see where you stand. You can see what kind of, let's say, statistical description of the surrounding where you are standing at that moment. So this is something I would like to show you. Not everything, but just. I thought it's my mobile in the pocket. Okay, it's on. You're still in the presentation. I'm still in presentation, yeah. Okay, that's the one. Just a little refreshes. So this is admin where you can, there should be something more visible. I don't know why it's not. Here you should be able to, okay, it's probably the monitor is too small. Okay, you can switch to English. I don't know, it should be okay, this is the first time it looks like this. So you start here, you upload the geospatial data, statistical data. Here you insert a PX file, the URL. We are testing together with the Geodetic Institute of Slovenia. It was also mentioned before, they are doing the programming. The SDMX files from the Eurostat. And I really wonder if the structure is so consistent regarding this geocoding and everything, as it was assured before with the health statistics. So when this is done, then you can manage different layers. You can, here you build the menu, for instance, for the municipalities. When you build the menu tree, then you link, for instance, these are variables from the PX files. Okay, names are in Slovene, but anyhow, means like population 0 to 14. And then you link these variables to the menu tree. You build this once, and then you can, of course, copy to all other levels of territorial units. Okay, now we'll stop here for something that was mentioned before. But is there a choke? Something's here. That's why I mentioned the SDMX, because I'm really interested if this is really the way it should be. You can see here, for instance, 65 plus, let means years. And you can find in our dissemination tables, people write the same variable like this. It's plus, or 65 space plus, or it's 65 or more, and so on. You can find like 4 to 5 different kinds of ways of how you can write one variable.
Should I answer you directly?
You can.
There's domains where STMX automatically checks against before dissemination.
That's perfect.
What we're doing in Inspire is the registry, domains, all that. This is already done before dissemination. So in Eurostat data, I haven't checked it. I haven't written a Python script, but
perfect.
As theory should say, there should be only 65 plus. There should be no other one. There should. But as I know how physics works, how computer science is working, I only say it loudly if I have tested it. I haven't tested it yet, so I cannot say. It should be only 65 plus.
Okay. We will see.
We will see.
We will see. Because the idea is so that maybe in the future we will have like a stage for Slovenia that will come from the national border down to 100-meter grid, and then stage Europe, of course, that our people can compare Slovenia to other countries down to NUTS 3 level, and is the easiest way is to get the data from Eurostat from SDMX files. Now you can, okay, there you can set the classifications for a particular variable. Also, there are many of ways you can, when you set the classification, okay, why there is a manual classification? Because often we notice that people take something from our website and then becomes official. And you know that with maps, there is even a book, How to Lie with Maps. They can make their own classification and present something in a very different way. So when you will choose a variable for a particular territorial unit, for a particular year, the first thing you will see will be official statistical interpretation of the data. If you take that, you can say, okay, the source and the copyright is from Statistical Office, and they say that the distribution of statistical data is like that. If you change anything else, it's your own responsibility. So there are many options how you can copy this classification to other territorial units and variables. Not so important, but regarding the Inspire, there are different translations. Okay, the application itself is multilingual. We are testing now. We have a trainee from Macedonia, and even supports the Macedonian alphabet. So these are short variable names. Short variable names is the names of the variables you will see when you will download the data. One way will be that you will download the shapefile, but there will be also, we will see later, according to the Inspire. So if here, now it's V1, most likely it will be the names of the variables suggested by the Geostat project. And here, as far as I understand, Inspire is not so strict how this should be named. I asked Udo Make, is also sitting here. He's a prominent member of the population distribution data specification team, or how to say. Yeah, and also Miroslav is also a member of that group. But we will use that one. So in at least for the population distribution, or the variables that refer to the population will be according to that specifications. Now, step forward from the Casper. Casper was only for the population 2011 census. Now we will include time series. I mentioned before, from 1995, we can have down to 100 meter grids. What is from before, it is, let's say, nearly 200% just to administrative units. You will have more freedom regarding the managing the client. You will be able to set legends, transparency, delineation. Regarding the authorized producers of official statistics in Slovenia, those who are not familiar with statistical production, usually statistical offices don't cover by themselves everything. We have, for instance, Bank of Slovenia, Ministry of Finances, and things like that produce their own statistics, but we disseminate them as official statistics. So they can, actually, we will upload their data on stage, and they will embed the application on their website. It will look like the application is running from their website, and also it can be said that only their variables are seen. There will be downloads of picture and geodata. So there is some Inspire compliance that was not in the Casper. I mentioned the responsive design. And obviously, we will have our web service for cartography. Namely, we discovered that the Google doesn't allow the export of the image. If you, for instance, choose the 100 meter grid and zoom into your house and set little transparency so that you can see the grid and your house behind, you cannot export the map together with statistical data and the satellite, for instance, behind. So that's why we will create our own web service. In Slovenia, it's like that. The statistical office is entitled to all the data that are produced in the country. So we can get from the mapping agency everything from orthophotos, aerial images, up to other territorial units. Now, something how the statistical office is involved with Inspire. I'm the member of the National Inspire team. Mapping agency is the national contact point, and is the leader of the implementation. Somehow we are only in charge for the population distribution theme, although the statistical office is not the primary. It's not maintaining the register on a primary level, because according to the Inspire, those are included who are the primary maintaining particular data source. But since the Ministry of Interior is doing nothing with this, we are responsible for the dissemination. This somehow falls on our shoulders. Now, metadata team will be established, and obviously, statistical office, that means myself, will have to be included. Statistical office started in 2008 to establish hierarchical grid systems, already regarding the Inspire recommendations. I'm mentioning before, so it has everything, IDs, and this is, for instance, 100 meter grid. I'm mentioning it because now other institutions are adopting this system, and it's important for us that they use the same system within the same projection. this is important for statistical confidentiality because, within the same coordinate system, if you change the origo of the grid slightly, then you can somehow overlap and you get the more detailed information than we would like you to see. And for instance, the environmental agency is now producing the data set where they will show the air pollution and noise pollution on 100-meter grids. So when we will combine this with population data, then we will see how many people live in certain kind of environment. And of course, then is the stage. The stage will be Inspire compliant regarding the metadata. We will produce the XML files. Most likely to be one file per data theme. That you can have also the Geostat project. I think that at least what we have produced so far, it means that there is one XML file and it will be for the population. It won't be for each variable like 65 plus or 15 to 64. It won't be XML for each of the variable. Of course, as you know, these files are then important for the discovery services. We will use national or EU Inspire metadata tool. We are more or less what comes out is the same. So then the network services. This Pi CSV from the OGC is implemented or is integrated in the stage platform. This will support the discovery service. Then thematic maps of variables that you can see in the client are available via WMS. So that supports the view service. And data are downloadable via WFS. That supports the download service. So maybe just for those of you who are not acquainted with this, basically when you create an XML, you get certain kind of description, and in this discovery service, you can either have direct link, or when you type, for instance, population, it should either return you the XML file, or it should link you directly to the source. I mean, if you have your GIS desktop, Esri or MapInfo, whatever, you can link with your server to this service, and if you choose to see only the raster maps, the graphics, then you will see this by means of WMS. It means just the pictures. And if you will choose to download the files, of course, one option will be directly from the application to download the shape files. But another option will be by means of these discovery services, where you will find the GML files. It means geometry with the variables that you will select, or, for instance, the territorial level with all the variables. It means like 2011, 100-meter grids with all the variables that are available for that level. Yeah, so basically that's what it says. When you get these GET capabilities, it returns you some sort of a link that comes from that XML metadata file I mentioned before, and links you either to visualization or to download of the data. Okay, maybe these are not just conclusions, but to sum up, one thing is that we really are trying to set up a sort of a dissemination model. All the data that will be presented in stage are regarded as open data. Ian described before what 4 stars means. It's the second time he did this for me already. So responsive design, already mentioned why is that for the mobile applications. Now it's integration with other dissemination databases. I was talking about SDMX is the first we'll try. And the application, the product as such, will be available to other NSIs, to statistical institutions as well. Basically what they'll have to do is from the English to you saw before, you can translate everything in your own language. Then, if they like, they can have their own application.
Super.
Thank you.
Thank you very much for this interesting presentation. The floor is open for discussions. Yes, Udo.
Yes. Well, I had a question. You have mentioned that you are dealing with time series.
Mm-hmm.
I think then you have to take in account that the statistical units are changing.
Yes.
So we have in Inspire, we have something, it's called evolution feature, which describes the changing, which is part of a unit is going to another part. So this is provided to do recalculation of your data. Do you use this?
It's like okay. To start from this, for every year you will have the geometry that is valid for that particular year. That's one thing, but you won't be able to see the data recalculated to let's say to that situation that is valid today. It means the data from 2010 you won't be able to recalculate just by means of stage to the situation 2014.
But then you have let's say gaps in your time series or something like that, because you have a new statistical unit coming in let's say 2010, yes, and before you don't have data, but part of the area which is represented by this new one is included in other values. So you don't, the values of the time series are not comparable all the time.
Mm-hmm. That's why there are grids included.
Okay.
Are you doing backcasting? Are you doing backcasting? Backcasting?
What is it?
Backcasting?
No.
No. Okay.
It's like that. We were discussing this a lot. There are tables. I was mentioning before this data portal we have. There are tables that are all the data are recalculated to the situation of territorial units as of today, let's say. So you can everything is recalculated. You have this time series, but you have then for the same variables, or let's say for the same statistical domain, better to say, for population, tables that when you choose 2008, you get just the geocodes for 2008, let's say for the municipalities. And when you choose 2009, if there are more municipalities, you get more or less. So actually we could choose either. But from this spatial point of view, it was just a decision that was made. I mean, it's difficult to keep the application as such simple for the users and to combine both. That's probably actually the main problem. Otherwise, there's no. It's very easy to do, as you propose.
Thank you. More questions? No?
One question I have. The download service you mentioned is valid for geographical data and statistical data.
Yes.
Do you have, and on the other hand, you said that you are not responsible for the geometry. It's done outside. Or did I misunderstood this? The question
No,
is, do you have license problems with this?
No.
I think
The geometries come from the mapping agency.
yes. And
Yeah.
in many countries, it's not allowed to provide this geometrical data.
Mm-hmm.
Yes, because they like to sell this.
Okay, I will tell you the interesting thing. If you go to the mapping agency and if you want empty, for instance, geometries, you have to pay. If you ask us to give you the number of population per municipality for the same geometry, you can get it for free.
Okay, good construction.
Yeah, it's because we are not allowed to charge anything,
Yeah.
but we are allowed to get those data. And that is something, maybe just, if I may, to refer to what was said before. I can, I can assure that the geometries that, I don't know, you said that from the your boundary maps come the geometries. I'm not 100% sure. Because when particularly if you want to provide a time series, sometimes I provide the data. For instance, I remember the agricultural statistics. You have to present on 5 minutes grid or something, and there were some. When the Eurostat checked our data, we didn't. There were some differences, and we are really, and they really tried to argue with me that I did something wrong, the Eurostat. But it was obviously simply they had the wrong geometries for NUTS 3, and so that's why I was skeptical with this geocoding and all the levels and SDMX. But Hannes says it's okay.
No, I'm theoretically saying it's okay, and I only vote on it if I have proved it myself.
Yeah, I know. But I didn't mention before that's why we additionally developed some controls within the applications. So when anything is out of the ordinary, the application informs you about that. And you will have completely a report of all the. I also didn't mention that the application is developed like this, that once you set everything, when a counselor for a particular statistical domain publishes a new table in our data portal, the state should automatically update itself with new data. So once it's set, I should have no work with that.
Hopefully.
Yeah.
Thank you very much, Igor. One finishing round. More question to Igor, sorry. Not. This is not the case. Then I'm now, because we have been talking so much, I would like to know what was the most striking what you learned today. What was the most interesting? What are you taking out of the workshop? What would you like to give us as a feedback here? Any ideas? If no one speaks up, I wrap up. But then I go home and cry because no one learned anything today. And we and all the presenters didn't do a good job. Okay, at least one.
Yeah, I learned that I feel Robin is taking the job away from Robin. This is what I learned today.
Yeah. Well, yeah, you need. That's the Dutch. The Dutch, they are always efficient. You know. No, that's not politically correct. But I mean, no. The Dutch have implemented table joints always. Yeah. Okay. Anything else?
So for me, it was interesting to see how well the GI and the statistics have evolved to cope. So it was a good message for me. Thanks.
Okay.
Well, from the point of an NMCA, I've learned that boundary maps are needed. You need administration units. In Austria, we've realized this last year, and administrative or the authorities, the federal states, opened up the data because the federal agency was not possible to open their data of administrative units. And what I've also learned now from Slovenia, we need a clear definition of licensing models because this is a striking example that you showed us.
But licensing includes responsibility.
Yes, that's why.
Yeah.
That's the only reason why. Not of getting money, but in creating responsibility and responsibility models.
Yeah.
That's the main reason. So we need some kind of stewardship model.
Yeah. Responsible data owner.
Yeah.
Mm-hmm.
There's one more thing that all data, even geodata, must be converted into triple star or stored into triple star and stored as a URI. to be linkable, and this was a real shock for me because imagine you have to every little piece of data must be transformed into a URI. This means something, and to a geo guy like me, it's something new, you know.
Yeah. Any more comments on that one?
Yeah, at what stage we have to put in the UID? On the stage of simple features? Open question.
Yes, that's also a good question for me. Huh? Yeah, I'm following your track on that one because how to implement that one. I mean, I'm just putting my Eurostat hat on with all the data we are disseminating. I mean, everybody can go to Eurostat website and download all the data in 1-to-1, 3 million scale, 1-to-1 million scale. And then if we provide that in as URI, that could be quite challenging. But I mean, as we learned from Ian, but I think he already left yet, and that's something else to attend to. Yeah, it's apparently feasible. Anything else? From the last rows, anything? No?
Maybe a last remark. In Austria, I'm working also on open government data, which is also then linked to linked data. And actually, we have seen that all people that were working in the sphere of open government data don't want to get in touch with Inspire. These are two things that don't go well together because Inspire is regulated and open data is free. You know, people from open data, they think free, they act free. They want to be, they don't want to be regulated.
Okay.
And so this is something that I have to make up in my mind how to deal with this, because you were talking about open, linked, inspired data. Open, you know, this doesn't go well together yet.
Okay, thank you very much for that feedback. I think that's good to keep in mind. Any more comments? None?
No, maybe it would be just appropriate to say I was referring to Eurostat a lot of time, but still I think that WhatsApp NSIs, we have to thank Eurostat to co-sponsors different of our expeditions regarding the JS and implementing Inspire, things like that.
Mm-hmm. Well, we're happy to do that, and we are always happy to receive so interesting results, because it shows, I mean, this session was also part of bringing out what the NSIs do in terms of GI and towards Inspire, and I think most of the GI world is not aware that the NSI is doing quite interesting and challenging GI work. And where the commuting flows or georeferencing, these are our base GI services, which actually, from a national mapping agency perspective, they would need to provide it, but they don't do that. I mean, if I talk to the Austrian colleagues, they have to get their quite expensive commercial licensed street network somewhere else because there is no official service for routing in Austria or something like that. You know, that's the question is where is our business model and what are we doing, what kind of services are we providing and what kind of GI work we are doing. So, more points? Otherwise, I'm wrapping up. What we heard today was, well, starting with me on SDMX and just introducing the whole session. We heard a little bit on follow-upping on SDMX, what you can do with the table join service by Athena. Well, for Bart, for Michael Grote, from Geonovum, for actually CBS, which we funded in Migrants, where actually I learned again, which we all know, if you go to Geonovum website and you look at the report out of that grant document, that still a reference implementation for table join service is missing, and they are still looking for reference implementation. And there's apparently still some fear in the community that the jobs will be taken away from the standard mapper. But there's a quality issue on that one, so this has two sides of the. We heard the presentation from Ian Cody on linked data, and the quote I want to give here is, "People used our data we never imagined." And I think this is something to keep in mind for our future work. If you imagine, you see that flood hug, right? I mean, who have ever imagined that statistics data would be used for flooding models or flooding emergency exercises. Followed after the coffee break by presentation of CSO Poland, and I think what's most striking for me is while you managed to process 39 million personal records on ArcGIS, I think that's a challenge, and that you should be congratulated too. And you made us aware that we can only address match 62% of your addresses. What you showed, how do you location, and I think this is not only your problem, it's a general GI problem, a general problem we need to not to address only in the GI community, also in the statistical community. How do we improve there? How do we progress there? Not only algorithm-wise, also database-wise.
But it's also a problem of registers and that.
Yeah, but I mean, it's a general problem which we need to be aware of, which you pointed out again here. 62% we can match, but the rest, this means less than 2/3 of the data we can match. Eva, I know that what Eva will answer to that one also.
But I'm still in my country. We managed to cope with the statistical office very much. And they are part of the register of territorial identification.
Yeah.
And they, as editors, cooperate with the editing because there are different inputs for the addresses from the cadastre, from building authorities, and so on.
Yeah.
And so if there is lack or some conflicting information, they come through a procedure to the responsible authority, and the address is updated. So it can vary, but they must be a part of the mechanism.
May I ask you to send me some information? I would like to put it on our grants dissemination for all the statistical offices. So if you could provide me some PDF or links to that one.
And then, in fact, they use this register data in their database. So it's closed cooperating mechanism.
Okay, that's already good. So maybe we can all learn, and you will have many people visiting you then.
Yeah.
I assume so. And last but not least, we heard from Slovenia about bringing out statistics out of our statistical domain and for even using time series data out to everyone, and providing reusable web services. And I learned at least that Google does not allow to save overlays. Was that correct, Igor? Was that what you said? That overlay on a zoom-in basis you cannot save?
You cannot export
the
picture.
You cannot export the picture?
Even if you want to make a print screen for your school seminar or something, you have to ask them, and they have like 1 month.
Okay.
They take 1 month to answer.
Well, I mean, then you have to set up your own orthophoto service. Okay. And I learned again, and I can stress it also as well, that the same reference grid is used in all the applications, and I can stress it, and I can stress it. I only support your notion on that one. With that one, any more comments? Otherwise, I thank you for attendance. I wish you a nice day here. Enjoy the football games tonight. Thank you.